As I promised you in my last video, I told you that the instruction for physics practicals have been released, and these are the apparatus we are meant to get for question 2. So I'm going to give you the expected questions that will come under this question 2 and what you must do. I will show you how the table look like. I will show you how to plot your graph, and I will show you how to answer some of the questions that are attached to this question 2 when it comes to the measurement of heat. So this one practically is under measurement of heat, right? Specific heat capacity. So if you are ready, let's go. So under question 2, this is the expected question. In fact, I'm very sure about it. This is how your question is going to look like. All right, this is 2016 and we are in 2026. This is past question. Can you observe the setup here? You are provided with a beaker, a thermometer, a stirrer, a measuring cylinder, a pulsing burner, a wire gauge, a 50-gram mass, a pair of tongs, water, tripod stand, and other necessary materials. Now, all you need to do is to observe the setup. If you're able to observe the setup, that's what you are meant to repeat during the practical. Your school might provide you with a candle, they might give you a bouncing burner, they might give you kerosene stove, they might give you gas stove. So please take note of this. Is that clear? Then what you're expected to do, they will give you a tongue where you clamp your mass, because your mass will be given to you. Is that clear? Yes, either your mass or whatever will be given to you. Take note of it, because that will be the source of heat. When it is heated, it is being transferred to the water, and then you have your beaker with water, and then you have your thermometer that will be given to you. So you are expected to measure the final temperature of this. You are expected to measure the initial temperature of this. Then you are expected to measure the equilibrium temperature after some specific time. Because if you observe, you see that stopwatch was included in the white paper. So you are expected to be given a stopwatch for a particular period of time. So these are the instructions. Using the measuring cylinder, measure 150 centimeter cube of water into the beaker. Record the volume of the water in the beaker. Alright, then calculate the mass m of the water. We are given mass equals density multiplied by volume, and we know that our density here is 1 gram per centimeter cube. Then measure and record the initial temperature theta at 0 degrees of the water in the beaker. I told you, initial. Then hold the 50-gram mass with a pair of tongs in the flame of the bouncing burner for 2 minutes. Can you see your time? So you need stopwatch for this. Quickly transfer the 50-gram mass to the water in the beaker. Then stir gently and record the highest temperature, theta 1, attained. You are expected to evaluate final temperature equals the highest temperature minus the initial temperature. So empty the content of the beaker and repeat the procedure above for other values. So what you'll be doing is that you'll be changing the volume of water inside this container. Alright, the first one will be 150 centimeter cube of water. Alright, the next one will be 200 for volume, 250 for volume, 300 for volume, and 350. Mind you, this can change. Is that clear? They can decide to use 50, 100, 150, and so on. But just know that that's how your practical is going to look like. Then you are expected to tabulate your readings. You are expected to plot a graph of m on the vertical axis and theta on the horizontal axis. Determine the slope s of the graph. Determine the slope s of the graph. Then evaluate k equals 50 over s. State 2 precautions taken to obtain accurate result. Define heat capacity. An electric kettle rated this. We are going to answer this question later. So for experiment under heat, these are some of the apparatus we've been given. You might be given a candle, please take note of this. Alright. Then as a source of heat, you might be given some of these things. Please take note of that. Why stopwatch is very important. Alright, because you'll be timing it. So the major thing is to hit your mass. All right, whatever mass is given to you, hit it, then you transfer to your beaker, and then you stir using your stirrer, and then you have a thermometer for measurement. So this is how you keep on repeating the procedure. Exactly, your source of heat must be there. You now heat this for maybe 20 seconds or 10 seconds as provided from the question. Then you transfer, then you stir, and then you observe your thermometer, and then you take your reading. Of course, your initial temperature will be 0. Then the obtained temperature here will become higher than it. But if you're able to carry out this practical as shown, then this is how your table will look like. Very important, please. Look at the table. This is how your table of value will look like. Alright. Now, your volume will be captured because your volume changes. I can see that the change is constant, right? At 50, 50, 50, 50. So in fact, you can guess your temperature with this. Yes, I'm telling you the fact. If you want to save time, once you're able to get your value for 150 and 200, check your question. If the values are constant, then you can be able to guess the rest. All right. Then after your volume, you are supposed to capture your mass, because your mass will be changing from 150 gram mass to 200 gram mass to 250 gram mass, 300 gram mass, 350 gram mass. So take note of this also. Then you are expected to record your theta, which is at 0 degrees. You have 30, 30, 30. Everything will be constant. Then after that, you are expected to record your theta 1. Okay, for 150, you have 41 degrees. For 200, you have 38. For 250, you have this. So this is how your table is meant to look like. All right. Then after that, you know that you're plotting theta on the graph. So your theta, how do you obtain theta? You say theta 1 minus theta 0. All right. So if you do this, you are going to have these particular values. So the graph will be shown in the next page. After you are done with this, you are expected to plot a graph of what? V against theta. So let's look at the graph quickly. This is how your graph is going to look like. All right. Make sure your title is captured. A graph of M in grams against theta in degrees Celsius. This is WAEC. You are expected to capture the title. If you fail to capture this title, you have failed. Please take note of that. Then your scale, make sure you capture your scales very well. Alright? Then you are expected to use at least the whole of your graph. If you observe this graph, you can see that almost every part of the graph was used. So don't go and draw one tiny thing somewhere on your graph. You are expected to use the whole of the graph. Then if the question come in this format where you plot mass against theta, then this is what you are having. Mass against theta, this is what you are having. So your graph will move this way. Your line of best fits will move this way. So what you will do is to ensure that your values are accurate. And if you observe also, I want to give you a secret. You see that your line of best fits, how many was he able to capture? If you observe, I have one. That is it. I have one, right? But when doing this, please try to capture like 2 or 3. If you're able to capture 2, you can draw this on this and move, or you can use this and go. All right. So your line of best fit, if you're able to capture up to 3, then your practical is so good and nice. Is that clear? So take note of your graph. This is how your graph will look like. If you're using 2 centimeters on y-axis or 4 centimeters, make sure it is captured. If you are using whatever centimeter, 1 centimeter or 2 centimeters, make sure you know what you are doing. Then how do you know the value of each of the lines? You now subtract. If this is 300 and this is 200, subtract 300 from 200, you have 100. 100 from 0, 100. 400 from 300, 100. Then you count how many lines are in between. Okay, If you're able to count the number of lines, then you divide 100 by the number of lines. So that gives you the value of each of the tiny lines. You do the same thing here. You can see the differences are 2, 4, 6. So I will now say 2 divided by the number of lines here. If they are 10 or 20, I divide them by 10 or by 20. I obtain the value of each of this line. I hope this is helpful. Then after that, you should know that you're expected to answer some questions from the graph. And these are the expected questions. The slope. Your slope is going to be change in y over change in x. So whatever is on your y-axis, okay, against whatever is on the x-axis. So you have the highest minus the lowest, and you are picking it from your graph. You pick it from your graph. You can see that my slope is here. Can you see? You pick from any 2 points from the graph, and I will suggest that you pick the lines of best fits. Okay, you pick the outer one and the inner one, whatever it is. All right, but make sure you know that this is your line of best fit and this becomes your slope. So you take your value for y. This is y2, this is y1, this is x2, and this is x1. So you take your reading and you are good to go. You are seeing that it's looking like a chair. Yes, that's how it is going to look like. So once you are done with that, these questions that are attached, you solve for your slope. Your slope will be negative slope. Is that clear? And your SI unit will be the SI unit of what is on the y-axis against the SI unit of what is on the x-axis. That's why you're having gram for y divided by degrees Celsius in x. That's why you're having grams per degree Celsius. I hope this one is clear. Then you see that the other question, our K, which is 50 over S, you divide 50 by your S, you have 1.8 degrees Celsius per grams. The precautions taken under this practical that you must know. Number one, I ensure that the 50-gram mass was held in the flame for only exactly 2 minutes. This is your precaution. I ensured that there was no delay in the transfer of the 50-gram mass from the flame to the water in the beaker. It was transferred quickly. That is another precaution. And then I ensured that at every new volume of water in the beaker, the 50-gram mass was made to cool to its normal room temperature before it was held in the flame again. Please take note of this. If not, it will affect your value. So what do you do with this? You can easily drop the mass into, since you are changing masses, you don't need to worry about this one. Is that clear? Then question 1b1, heat capacity is the quantity of heat required to raise the temperature of a substance by 1 Kelvin. You can be asked to define heat capacity. Then you can be given a mathematical problem. You should know that if the question comes in that format, then you are expected to solve. Let's look at the question. They said an electric kettle rated 1.2 kilowatt is used to heat. This is the source of heat. This is the heat. This one will not be heat. This is heat lost now. To heat by 800 gram of water initially at temperature of 20 degrees Celsius. Neglecting heat losses, calculate the time taken for the kettle to heat the water to its boiling point. Take the boiling point of water to be 101 degrees Celsius. Specific capacity of water equals 4,200 joules per kilogram per Kelvin. So take note of the way the question will come out in your exams. And if that's the case, you should know that heat gained by electric kettle equals heat gained. You should know that the heat generated by electric kettle, which is heat lost, equals heat gained by water. Heat generated by electric kettle, since it's coming from electricity, will give you power multiplied by time. And we know that power equals current multiplied by volume. We know that power equals current multiplied by voltage. But since we are giving power directly, then we know that we have 1.2 kilowatt, which is We have power to be 1.2 kilowatt, which is 1200 watts. Our time, we are going to make it the subject of the formula. So when you equate these two, you now have M of water multiplied by C of water into theta 1 minus theta 2. And our mass is 800 grams, which will give us 0.8 kilograms. Then our C of water is 4200 joules per kilogram per Kelvin. Our final temperature of water is 101 degrees Celsius. Our initial temperature of water is 20 degrees. So when you apply that to this is what you have. Okay? PT equals MWCW into theta 2 minus theta 1. When you substitute, everything gives you T to be equal to 226.8 seconds. So that is how your question for both alternative A and B might look like when it comes to the specific heat capacity, which is the measurement of heat. Now, still under question 2, why it can be funny sometimes, okay? The fact that they listed this apparatus or instruments doesn't mean that they are going to use all of this. Since we're having alternative A and alternative B, they might decide to pick any of this because you can see pendulum bulb here, you can see beaker containing water, okay, you can see measuring cylinder and the rest. So they can decide to take this in another format, and if they do, this is the second question that can likely come out under question 2. Now this is your question. You observe this. This is one of the question for 2012. Okay, observe the question. You can see that you have your beaker here. You have your beaker here. Okay, since you have your beaker and this is your what? This can be your meter rule. Is that clear? Or whatever device. Now you have your beaker here. All right. Then you have your retort stand here and your cork. Then you have your search pin. If you observe, they mentioned pin in one of the uh, questions. Let's take a look at it. If you look at this particular one, you will see that they mention optical pin in question 1. Okay, so if that's the case, we'll assume that it can likely come out under this particular question. So what are you meant to do here? You are meant to have your measuring cylinder, you are supposed to have your retort stand, and then you are supposed to have your pin that you are going to be using to measure. So with this, how is the practical going to look like? This is how it's going to look like. Use the diagram above as a guide. Carry out the following instruction. Place an optical pin object at the bottom of the measuring cylinder. At the bottom, can you see the measuring cylinder here? This one. So look at your pin here. Then pour water of volume 150 centimeter cube into the measuring cylinder. So we are expected to pour water of volume which is equal to 150 centimeter cube, okay, into this cylinder. Then after you are done, measure and record the real depth OS, which is equal to H. This is your H. I'm supposed to measure the real depth OS. Then move the search pin up and down and locate the image I. You are supposed to move the search pin up and down. This is your search pin, okay, up and down. And what are you supposed to do? You are supposed to locate the image I and record the apparent depth IS, which is your small h. So we're having two h here. We're having the first h, which is real depth. Then we have the second h, which is your apparent depth. And this is where you can be able to locate the image formed. Then repeat the procedure for V, volume of water, equals 175, 200, 225, 250, 275. In each case, measure and record the volume of H. So repeat the procedure and do this. And the corresponding values of small letter h, tabulate your readings in the space provided. That is what you are meant to carry out. Then you are meant to plot a graph of h on the vertical axis and small letter h on the horizontal axis. Determine the slope s of the graph. State two precautions to ensure accurate results. You can be asked to state Snell's law of refraction, and a glass of thickness T and refractive index N is placed on a dot of ink. If the dot of ink is viewed through the glass, express the displacement D of the dot in terms of N and I. So this is how your table will look like. Your volume, if you know this one very well, this is a very simple practical. Your volume, then your real depth, then your apparent depth. Alright, then if you're able to achieve that, this is how your graph will look like. Your title, a graph of h in centimeter against small letter h in cm. Then your SI, then your scale will be captured. So if you do that, you can see h here. Make sure you use your graph properly. Use almost all the graph. Your graph of h against small h. And this is how your line of best fit is going to look like. And if you're able to pick up your gradient, okay, from the outer to the inner, please pick any 2 points from the line of best fit and then draw your slope out. Is that clear? So once you're able to do this, you are able to get your slope when it comes to the calculations. Now let's look at how your slope is going to look like. The slope S equals H2 minus H1 over small letter H2 minus H1, which will give you 1.33. You can see that it's giving you the refractive index of water, close to the refractive index of water. So that's what they are expecting you to find or to look for. Then the precautions here, I ensured that the water in the cylinder was still, not disturbed when viewed from the top of the cylinder. I avoided error of parallax in aligning the search pin with the image of the optical pins. Then Snell's law of refraction states that the ratio of the sine of the angle of incidence to the sine of angle of refraction is constant for a given pair of media. Okay, then your thickness T of glass is the real depth from that question. Your A is your refractive index of glass, your D is the displacement. Let the apparent depth be this. If you're able to solve this, you solve them simultaneously. If you put equation 1 into equation 2, you have N equals T over T minus D. Cross multiply, you now have N into T minus D equals T. T minus D equals T over N. Then D equals T minus T over N. Is that clear? So take note of this particular part. That is that for the second practicals. I've dropped the other questions. Check them out and prepare adequately.